Okay, in this video, we are going to look at logarithmic functions grade 12. This is part 6 of 6. Okay, so we are going to start with sketching a logarithmic graph. Okay, sketching a logarithmic graph. Okay, you are given sketch the log graph with equation y is equal to log of x minus 3 base 2. Okay, let's sketch the graph. To sketch a logarithmic graph, always get the following three things. Okay, always get the following three things if you wanna sketch a logarithmic graph. The first thing is get the vertical asymptote. The second thing is get the x-intercept, and the third thing is get a random point. Okay, so a logarithmic graph will always have the vertical asymptote, always, and a logarithmic graph will always have the x-intercept. Okay, always. And in the case of an exponential graph, if you are requested to sketch an exponential graph, you are also going to need to get three things. The three things in the case of an exponential graph will be a horizontal asymptote, the y-intercept, and a random point. But in the case of a logarithmic graph, you need to get the following three things, which are the vertical asymptote, the x-intercept, and a random point. Okay, let's get these three things, and then we can now sketch a logarithmic graph. If you get these three things, you will never go wrong. Okay, so from the equation, you can see the vertical asymptote is at x is equal to 3. Okay, and we can show this on a Cartesian plane. So this is the Cartesian plane, this is the x-axis, and this is the y-axis. So you have your vertical asymptote at x is equal to 3. This is the x-axis, and there's 3. So you have your vertical asymptote at x is equal to 3. And then after that, you need to get the x-intercept. To get the x-intercept, you let y equal to 0. Okay, so this is y. You let y equal to 0 to get the x-intercept. Okay, so this is y, and you let it equal to 0. So you are going to have 0 is equal to log of x minus 3 base 2. And then now you can solve for x. Okay, so you have x minus 3 is equal to, this is your base, it is written as the base, and everything that you have on the other side is your exponent. Okay, always, you can see this is written as the base, right? And what you have on the other side is your exponent. Okay, you carry on. Now you have x is equal to 2 to the power of 0 is 1. You bring the negative 3 to the right. Now you have 1 plus 3. This is equal to 4. Okay, so you have your x-intercept at 4, and the coordinates are 4 and 0. These are the coordinates of the x-intercept for this graph. Okay, you can show that on the Cartesian plane. So this is the point on the x-axis. Okay, the coordinates are 4 and 0. Okay, after that, you need to get a random point. Okay, so to get a random point, you can use any value. Now, when you check your sketch from what you have here, you can see you have your x-intercept there, and you have your vertical asymptote there. From this, you can tell that the log graph does not exist on this side. The log graph will only exist on this side, not on this side. So I can use 5, 6, 7, 8, 9 to get my random point. Let me use 6. So x is 6, and what is y equal to? I'm going to plug 6 in there to get the y value. Okay, let me use a calculator. Okay, I hope you can follow. So I have log of x minus 3 base 2. So the base is 2, and in bracket I have x minus 3. So x is 6. I'm going to have 6 minus 3 and this is equal to 1.6. If you can keep your answer to one decimal place, it's 1.6. Okay, so 1.6. This is the y value. So you can show this on the Cartesian plane. So you have 6 and 1.6. 1.6 is somewhere there between 1 and 2. Okay, 6. Okay, somewhere there. And the coordinates are 6 and 1.6. Okay. Okay, maybe let's say you don't want to have a decimal y value. So you can try other x value to see if you are going to get a y value which is not a decimal. Let's see, you can do that. Let's try with 7, okay? So let me say, or you actually need only one random point. Okay, but I'm going to get another random point. You only need one, and you can sketch your graph. You can see I can sketch my graph with only these 2 points and the vertical asymptote. This is enough, but I'm going to get another random point. Let's get that. So let's use 7. Okay, when x is equal to 7, what is y equal to? Okay, let's use the calculator. When x is equal to 7, what is y equal to? So you can see in bracket you are going to have 7 minus 3, and this is equal to 2. You can see. Okay, so the y value is 2. Now you have a y value which is not a decimal. Okay, you can also show these coordinates on the Cartesian plane. So you have 7 and 2. 7 and 2. Okay, there. 7 and 2. Okay, so now you have 2 random points. You actually need only one random point. So now you can see the graph is going to be like this. Make sure you don't cross the vertical asymptote. Okay, so it's going to be like this. You can see. So this is the graph of y. Okay. Okay, we carry on. Now we are going to look at the full standard equation of a logarithmic graph. Okay, the full standard equation of a logarithmic graph. Okay, this is the equation that you have to expect. Okay, we are going to look at all these letters. Okay, so for the letter A, you don't need to worry about the letter A because the letter A is equal to 1 for grade 12 curriculum. If you happen to get the value of A negative, then you have to understand that the graph is reflected about the x-axis. Okay, and B is going to give you the information about the base. Okay, this represents the base. Okay, and what is K? K is going to give you the information about the vertical translation. K gives you the information about how many units the graph is moved up or how many units the graph is moved down. Okay, so K is giving you the information about the vertical translation. How many units upward or how many units downward. Okay, so if you happen to have, if K is greater than 0, meaning positive, meaning you have positive day. If K is greater than 0, meaning you have positive day, right? In this case, you have to know the graph would be shifted K units up. Okay, if you have plus day, the graph would be shifted K units up. Okay, if K is less than 0, meaning negative, so you have a negative day. If K is less than 0, you have to know that the graph would be shifted K units down. Okay, if negative, down. If positive, up. Okay, and what about H? The letter H is giving you the information about the vertical asymptote and horizontal translation. Let me say that again. The letter H is giving you the information about the vertical asymptote and horizontal translation. Okay, so to get the vertical asymptote, the vertical asymptote is at x is equal to h. Now, if h is greater than 0, meaning you have positive day. If h is greater than 0, then the graph would be shifted h units to the left. Okay? If you have positive day, the graph would be shifted h units to the left. If h is less than 0, meaning you have negative day, then the graph would be shifted h units right. Okay? So when you have negative, right. When you have positive, left. Okay? You do the opposite. Positive with left and negative with right. Okay, so this is the full standard equation of a logarithmic graph. Okay, now I have some few examples that we are going to use so that you can understand this standard equation in more details. Okay, let's use these examples to understand this. Okay, so identify the equation of a logarithmic graph. Okay, examples. So we have examples here. Now the question is, identify the letters A, B, H, and K in each of the following equations. Okay, question 1, you are given y is equal to log of x, right? You are given log of x base 3. Okay, so this is what you are given. Now you are requested to identify A, B, H, and K. Okay, what is A equal to? You can see A is 1. There is an invisible 1 in front of the letter log. Okay, A, there is an invisible 1 there. So A is equal to 1. Okay, and what is B equal to? B is the base. B is equal to 3. Okay, you can see that. And what is H equal to? H is always written in bracket together with X. Okay, in this case, you don't have H. So H is equal to 0. And from this, you know that the vertical asymptote is at X is equal to 0. Okay, and this is actually the y-axis. Okay, X is equal to 0 is the y-axis. So in this case, the y-axis acts as what? As the vertical asymptote. Okay, and again, there is no horizontal translation. Okay, there is no horizontal translation. So the graph did not move to the left or to the right. There is no horizontal translation because h is equal to 0. Okay, now what is k equal to? You can see there is nothing there. So k is equal to 0. Okay, and you can conclude that there is no vertical translation because k is equal to 0. So the graph did not move up, neither did the graph move down. Okay, because k is equal to 0. Let's move on. Let's look at another example. Okay, now you are given y is equal to log x plus 5. Okay, what is a equal to? You can see there is an invisible 1 there. So a is equal to 1. There is an invisible 1 there. And what is b equal to? B is equal to 10. Okay, b is equal to 10. When the base is 10, we don't write 10. Okay, we don't write 10. Just know that whenever there is nothing there, the base is equal to 10. We normally don't write 10. Okay, the base is 10. Okay, and now what is h equal to? You can see h is equal to 0. You can see that h is always written in bracket together with x, but you don't have anything there. So h is equal to 0. Again, the vertical asymptote is at x is equal to 0, and this is the y-axis. Because h is equal to 0, the vertical asymptote is at x is equal to 0. This is the y-axis, and again, there is no horizontal translation. Because h is equal to 0, there is no horizontal translation. Okay, you can see that. So the graph did not move to the left, neither did the graph move to the right. Okay, and what is k equal to? K is equal to 5. Okay, you can see k is equal to 5, and from this you can conclude that the graph shifted 5 units up. Okay, let's move on. Let's look at another example. Example number 3. You are given y is equal to log of minus 2x minus 2 base 2. Okay, what is a equal to? A is equal to 1. There is an invisible 1 there. Okay, a is equal to 1. And what is b equal to? B, your base, the base is 2. You can see that. Okay, now to get h, you always want to make sure that the coefficient of x is a positive 1, not a negative value. Always make sure the coefficient of x is 1, a positive 1. In this case, you can see the coefficient of x is negative 2. So before you can identify your h, make sure the coefficient of x is a positive 1, okay, not a negative value or any other value. So in this case, you are going to factorize this so that you can have the coefficient of x a positive 1. So from this, when you factorize, you are going to get this, okay, right? You have base 2 and you have this. When you factorize, you get this. So you can see you have negative 2 times x. You are going to get negative 2x. Negative 2 times 1, you are going to get negative 2. So you factorize. Now you can see the coefficient of x is 1. Inside the bracket, you can see the coefficient of x is 1. Now from this, you can tell what h is equal to. So h is equal to 1, right? After factorization, h is 1, and the vertical asymptote is at x is equal to negative 1. Okay, you take the opposite value from plus 1 to negative 1, right? Always you do that. So you have your vertical asymptote at x is equal to negative 1. Okay, you can try to sketch the graph. You will see that the vertical asymptote is at x is equal to negative 1. You can try to sketch the graph. Okay, and now you can see that there is a horizontal translation by how many units? 1 unit to the left. When it is plus, it is to the left. You can see plus to the left. So the graph shifted 1 unit to the left. Okay, let's carry on. Now, what is k equal to? There is nothing there. This is a complete bracket. You open your bracket, you close, you don't have anything there. So k is equal to 0. And again, no vertical translation because k is equal to 0. Okay, let's look at example number 4. Example number 4, you are given y is equal to log of x minus 3 base 2. Okay, you are given y is equal to log of x minus 3 base 2. A is equal to 1, right? There is an invisible 1 there. B is equal to 2, right? And h is equal to negative 3, right? And your vertical asymptote is at x is equal to 3, right? The opposite as we did in the previous example. So from negative 3 to the vertical asymptote is at x is equal to 3. Okay, from negative 3 to a positive 3. This is how you do it. You can try to sketch the graph. You are going to see that there is a vertical asymptote at x is equal to 3. Okay, so again, there is a horizontal shift or a horizontal translation by 3 units. 3 units to the right when it is negative to the right. Okay, so the graph shifted 3 units to the right. And again, k is equal to, there is nothing there. You don't have anything there. K is equal to 0. So there is no vertical translation. You can see that. Okay. Please, I want you to comment in the comment section if you are enjoying the videos, okay, so that I can be pushing more videos for you, okay. Okay, finally, we are going to look at the difference between an exponential and a logarithmic function. Okay, we are going to tabulate the difference between an exponential and a logarithmic function. Okay, so you have an exponential function and a logarithmic function. Okay, let's tabulate the difference between the two. Okay, so an exponential graph will always have the y-intercept. Always, an exponential graph will always have the y-intercept. Okay, how about the logarithmic function? A logarithmic function or a logarithmic graph will always have the x-intercept. And an exponential graph will sometimes have the x-intercept, but not always. Okay, and a logarithmic graph will sometimes have the y-intercept, but not always. Okay, let's carry on. An exponential graph will always have a horizontal asymptote. Okay, sometimes the x-axis acts as what? As the horizontal asymptote. Okay, when it comes to a logarithmic function, a logarithmic graph will always have a vertical asymptote. Sometimes the y-axis acts as what? As the vertical asymptote. Okay, the inverse of an exponential graph is a logarithmic graph. Okay, and the inverse of a logarithmic graph is an exponential graph. Okay, we are done with part 6 of 6 on grade 12 functions. Until next time, I will talk to you soon.